I was mentally thinking out loud. All right, so you got this lovely problem. What's that little square mean when I do a tangent of 120? Okay, mathematicians are lazy. But trig functions, they don't want to have to write it out as parentheses, tangent of 120 squared. That's what it means. But mathematicians are lazy, they don't have to write the parentheses, so they said, oh, we're just going to put the little square up there on the tangent. But it means find the tangent of 120, square your answer.
Well, yeah, their proof is probably going to be vertical.
Yeah. Well, if you write a lot of math problems, maybe it would get tedious. I don't know. So we need the tangent of 120. So where's 120? Okay, tangent of 120, second quadrant. I'm going to come down to the axis, which makes my reference angle what? Makes it 60. So I need the tangent of 60. Okay, tangent of 60 would be square root of 3. Technically, you should go, oh, it's in the second quadrant, so it's negative, but it really doesn't matter why. Because you're squaring it, so you really don't have to check it since you're squaring it. Okay, then you're going to go secant of 240. 240 is quadrant 3, so when you do your reference angle, you're going up. So if this was 240, you just went up to the 180 line, which means it's a 60. So I'm looking up secant of 60, which is one. Cosine of 60 is a half, so when I do secant, I flip it, and I would have 2. And it would be in the third quadrant, it's negative. Okay. All right, 270. This is one of the special cases. Where is 270?
It's on the line, isn't it?
On the
line, up the line.
270 is on the line. So how do you do the ones on the line?
Zero.
They're on a quadrant line.
Zero degree.
Okay, it's either got to be a 0 or a 90. 270 is on the same line as 90, so you use 90.
Let's do a 9.
So if you're doing a 180, you use 0. You're on the same horizontal line. So sine of 270, same thing as sine of 90. Sine of 90 is 1. Now, how are you going to know positives or negatives? You're not in the quadrant.
You're on the bottom. You're on the bottom.
You're on the bottom. You're on the negative side of the y-axis. If you're on the bottom side, it's negative. If you're on the top side, it's positive. Okay, so you're going to have negative 1 times, now, how do I do a negative 210 degrees?
Instead of going up and over, you go down and up.
Yeah. Negative angles went around backwards. So where's negative 210?
It'd be in the second quadrant, wouldn't it?
It would be in the second quadrant, because you're past 180. Okay, so how far past 180 am I? 30. So there, and since I draw my triangle down, that's a 30-degree angle. So I need cotangent of 30. So I have to go to tangent of 30, and I have to flip it.
It's 3 over square root of 3.
Which we just decided, though, when you shortcut, you know that flip is just square root of 3. Because when you turn this one upside down, you just get square root of 3. Okay, positive or negative in the second quadrant.
It would be negative.
Cotangent in the second quadrant is negative, so that would be a negative. And then you just have to crunch the numbers and simplify the answer.
So that would be what? 9 plus negative 2.
Okay. Squaring the square root will give you a 3 plus negative 2, so that adds up to a big whopping 1. And so I would have, 1 over the square root of 3, which, if I rationalize it, it's going to become 5 times by square root of 3 on both top and bottom. I'll get square root of 3 over 3, and there's my answer. Boy, howdy, that was good fun.
Sure.
So now guess what we're going to do?
Do it all again in radians.
Exact same thing in radians. You work it exactly the same way. You just have to start with an angle in radians instead of an angle in degrees. Okay. The biggest problem you have with radians is figuring out what quadrant you're in. That's the tricky part of radians. So if I said to you, let's do it, that's a nice simple one. If I said figuring out where the tangent of 7 pi over 6 radians is at. Okay, first of all, how do you know it's a special angle value at all?
pi over 6 on the bottom.
If it has one of these numbers on the bottom of it, technically this top one is like having a 1 on the bottom. If it has one of those digits on the bottom, you know it's special. Okay, so 7, 5, or 6. Would you all agree that 7/6 is the same thing as 1 and 1/6?
Maybe.
Okay, because that's telling you you need to go 1 pi and a 1/6 more.
Oh, yeah.
You have to remember, 1 pi is how far on the clock?
All the way around. 180.
1 pi is halfway around. So if I'm at 1 and 1/6, I'm 1 around,
And you go 30.
plus a 6 more. A 6 more is not going to be past this halfway line. So you know you're in the second quadrant, and the beauty of it is, if there's a 6 on the bottom, your reference angle is pi over 6. If there's a 4 on the bottom, your reference angle is pi over 4. It's that easy. So all you need to do is go pi over 6 tangent. My answer would be square root of 3. Now, why am I going to, where do I need to check if I, to avoid losing a half a point?
Negative and positive.
You self-check positive, negative.
Tangent's positive.
In the third quadrant, it's positive, but you do need to check. What if I threw you cosecant of 2 pi over 3? Okay. Where are you if you're at 2/3 of pi?
Well, you're being the second quadrant, it's not quite a whole
Because
lot.
it's 2/3 the whole pi. No, so you're not around to the 180 line. Because this is a whole pi right here. But are you past half? You need to ask yourself, is 2/3 past half? It is, it's past half. So you're in the second quadrant, you got a 3 on the bottom, so you're just going to do pi over 3. Okay, by the way, to get homework credit on this assignment on that worksheet, I better see a picture drawn every time showing me where you're at. Just answers means you copied my answers.
This is on the special angle.
That worksheet, yes. Okay. So now I need to do cosecant. I'm looking up which trig function. Sine. So I'm coming down to sine of pi over 3. And just so I don't lose anybody, yes, I flipped that upside down. And then when I rationalize it, yes, I will get 2 squared 3 over 3. And I did it again. Doggone it. I'm in a quadrant where it's positive. I keep doing positive ones. Sorry. It's still positive. You really will have to work it out about negatives, but I keep missing them. Okay. One more of these.
You're going to do more of the easy ones, or you're going to do a hard one?
I'm not. I still need to show you how to do the backwards version, so I just want to do one more of these kind, but I needed you to have to figure out where on earth you were. I want to do backwards. I want the cosine of 7 pi over 2. No. What's the cosine of 7 pi? Where are you?
Right where you began.
Nope.
No.
It'd be odd.
No.
Because you got to remember, 1 pi is over here.
Yeah, you see
So when you're back,
Over there.
that's 2 pi.
So you'd be on the one.
Be on the one on the
So odds are over here: 3, 4 pi, 5 pi, 6 pi, 7 pi would land you over here. So it's the same thing as a 180. Unique cosine of 7 pi are the same thing as 180. Which angle do you use if you're on that quadrant line? You're on the same line as 0,
Yeah.
so you use 0. So you go, what's the cosine of 0? 1. Which side are you on, the positive side or the negative side? You're on the negative side. So it's negative 1.
There you go, you got your negative.
So 0 cosine. 7 pi, yeah. Yeah. You have to remember, 1 pi is halfway around. So 7 pi is over here. Because you went 1 pi would be here, 2 pi would be back, 3, 4, 5, 6, 7. You just have to keep going.
Because
you're on the negative side of the x-axis. The beginning is always here.
Oh, okay.
Beginning is always there.
Yeah, I know.
Yeah. We're not navigating now. Zero is always over here. Same as the clock. No, that clock helps us a bunch. All right. How am I doing? The last page of your worksheet asks you to go backwards. This is not that big a deal. We'll do hopefully one in degrees and one in radians here. So it's going to tell you the value of the trig function. So it might say sine is negative square root of 2 over 2. They want you to find the angles where that it equals negative square root of 2 over 2. Okay. What you need to do is 3 steps. You need to first find the quadrants. There'll be more than one on most cases, unless you're on a quadrine. Find the quadrants. Find the reference angle. And then name the angles. You do it the same way for both degrees and radians. Makes no difference. You do those same set of steps. So, where's sine negative?
It's in 3 and 4.
It's negative in third and fourth. So you go, okay, I could be in the third quadrant or I could be in the fourth quadrant. So, Cody, have a seat. It's not like you have to dash out the door first. And now, Cody, you'll be happy. No, you can talk.
Okay.
Okay. He hit the button, sorry.
You wanted candy.
Now you have to hold the door for everyone and wait, because you disturbed them too. Okay, we know it's 45 degrees where sine equals square root of 2 over 2. So, you know your reference angles are 45. So then what's the angle? What's the angle from here to there? This is 180 plus 45. So that would be 225. Now, how do you do the one, I don't have any other bright colors. How do you do the one from here all the way around to there? You do 360 minus 45. 360 minus 45 would be 315. Okay. And there would be your two answers. You're not going to keep going around and around and around and around and around forever. We're just going to go around once and quit. So you should get two answers in most cases. Okay. If I had done that same problem, but I said do it in radians, you had the exact same problem. You'd have done pi over 4. So then you have to add fractions.
Door open, Cody.
That would be what?
This is 1 pi plus 1/4. What's 1 plus 1/4? 5/4. Okay, this is 2 pi, which is 8/4, to make a common denominator. And back up a fourth is 7/4. So you have to do fractions to do radians. You have to be able to add fractions. A little bit more, they'll get you stuck on.
Yeah, let's try it and
Hey, let's tell Cody, let's right now. I want you to practice more than that. Yes, worksheet. There's you're doing this and that. The other one, yeah. And I just had a couple little things. Your homework, just we're going to review tomorrow, is just to do those 3 and this one regression problem on the calculator.
How do you go from pi over 4? I get that, but then how do you go from pi over 4 and then?
Okay, because that line there, because we did 360, yeah, 8/4 minus 1/4 is 7/4.
But you're adding something.
Yeah, because you got to remember, pi over 4 is 1/4.
Experience story for me.
Oh, buggers, not again, doggone it.